Today's our topic is hypothesis testing, which is one of the another kind of inferential statistics. When we have the population parameter value and we use the sample data to verify or nullify it. So what we are going to study is to introduce the concept of steps in hypothesis testing. Hypothesis testing is basically we make a statement regarding population parameter, and then based on sample data we decide to either verify or nullify it. Like, for example, if there is a statement that mean blood pressure is equal to 120 millimeter of any patient or any group of the sample. So this is the statement we it is about the if it is about the population parameter, that is mu. Mu is equal to 120 millimeter Hg. So what we will do, we will collect the sample data, and then we, based on the sample data, we will check that either the sample value also has the mean value is equal to 120 or not. So we have two scenario when we are conducting an experiment, that the statement made in the hypothesis can be a true or can be not true. So there is always two statement. One is that either the mean will be the true, and another one is that the mean won't be true. I mean, we will not get the same value as it is given in the hypothesized value. So after that, just looking at the two mean value, it is not easy to make any decision. There are six steps of hypothesis. Like in the first statement, we make the two statement. Like in our example, the mean is equal to 2. It is our hypothesis, which we are going to actually test it. And then there is one more hypothesis that would be the possibility that mean won't be equal to 120, which is in our which can be obtained from the sample. Then we define some level of significance, that is the probability of error, which will be tolerate about that statement and the from data evaluation, because uh, in the real sample it can be exactly contains all the population value. Like if we have a population of millions and we are taking a sample of 1,000 only, so obviously there will be some difference between the population value and the sample value. So what how much percent of error we are actually expecting to the deviance between the data observation and that our hypothesized statement. So then we decide a test statistics that which will help us to check the deviation from our sample data and our statement. And then we decide the rejection region or critical region. These are also synonym in the theory of statistics, that we set the rejection criteria. We set the rejection criteria based on the value of the test statistics. So we are going to study today the first step and the second step and basically the fourth step in detail. The test statistics actually has too many a scenario. It is based on too many conditions. So therefore, the detail will be discussed in the other lecture. And the computation are basically we can do in any statistical software. Our main concern will be the SPSS, and then based on the above steps we make the resultant conclusion. So first step is making the statement of hypothesis. We make the statement based on both possibility, that the statement will contain the parameter value, or if the statement does not contain the parameter value. The statement which contains the parameter value exact value, we call them null hypothesis, while any statement contradictory to the null hypothesis is alternative hypothesis. For example, if we are talking about that our mean is equal to 120, then alternative hypothesis will be mean is not equal to 120. There's one more thing, that one more clue to identify the null and alternative hypothesis is that the null hypothesis always contains inequality, and the alternative hypothesis always contains a non-equality. For example, In our this example, the mean is equal to 120 will be our null hypothesis, while the statement which is mean is not equal to 120, it will be our alternative hypothesis. And in the layman language, I mean, in general life, the statement of null hypothesis typically imply of no difference or no association between the estimated and the response variable in our application. For example, if I'm saying the null mean is equal to 120, it means mean is not different than 120. And mean is not equal to 120, it means mean is different than 120. That is why we actually specify the mean is equal to 120 as well, null hypothesis, and mean is different than 120 as alternative hypothesis. And there's one clue about the tip about association. If someone is using the word association, for example, that the smoking leads to lung cancer, it means smoking cause the lung cancer. There is an association of the smoking status and the lung cancer status. It means that a smoker, if in null hypothesis we are saying that smokers have equal chances of getting of lung cancer as that of non-smoker. And in the alternate hypothesis we are saying that smoker have different chances of having lung cancer as compared to non-smoker. And this is basically what is required, that we want to basically prove that smoking causes a lung cancer. That is why alternative hypotheses usually refer as researcher hypothesis also. And then we have one more donation, that null hypothesis is denoted by the an H naught, and alternative hypothesis is denoted by the H1, H1, HA or H1. You can use any one of the any one of the notation for null or alternative hypothesis. Before going to the step number 2, we need to actually study some of the concept. This is about the error which we can make when the true situation in the population and when we have the some other situation we obtain from the sample. The row represent the condition in the population, I mean the true situation in the population, and the column represent what we obtain from the data. So there are four possibilities. For example, we started with the with the hypothesis that mean is equal to 120 millimeter Hg. And when we obtain, it can be happen when we go to the sample, the situation can be yes, we obtain the mean is equal to 120, and there is a chances that maybe we obtain mean not equal to 120. Like the sample data values the sample data values does not prove the mean is equal to 120, although it was true. So what will be the what is the condition that here, that in the population it was true that all the people have the normal BP, that is let's suppose 120, and we collect the data, and after collecting the data we also prove that yes, the mean is equal to 120. That is our null hypothesis was true in the population, and we prove that yes, the null hypothesis also true. Graphically, if we see that our null this is the blue area is a distribution of the null hypothesis, and this area, the second curve, is about the distribution of the alternative hypothesis. Let's suppose our null hypothesis has a mean value 4 and the alternative hypothesis the mean value as 7. So, if we start an experiment with the assumption that our null hypothesis is true, and we got the same area, like the area which is given here in the blue area, and we also prove that this is the area of the 1 minus alpha. So we also prove that this that the null hypothesis is true. It means we are not making any error, and the probability of not committing any error is we call it 1 minus alpha. So 1 minus alpha is the probability when we accept the true null hypothesis. Then there can be another condition. we start our experiment with the assumption that in our population the mean is equal to 120, or we can say that the null hypothesis is true. And then, but what happened in the sample values, maybe we get any observation which deviates far away from the 120. So in that condition, due to some observation or due to some sampling error, we reject the null hypothesis, although it was true. Okay, it was true, but due to sample error, due to sampling collection, or some due to some other issue, we accidentally reject the null hypothesis. I mean, we say the null hypothesis is not true. So this is a kind of error. Like in the population, all participant all people have the mean is equal to 120, but the sample values deny it defies the value of the null hypothesis. So this kind of error we call them type 1 error, and this is the probability of type 1 error, we call them alpha, and it is also called as level of significance. Looking at the graph, this area, the blue area is the alpha. The blue area is the alpha, which imply, I mean, all observation would lie along the null hypothesis, but the few observation basically coincide with the distribution of the alternative hypothesis, and researcher sees this one and neglect this one. So these value actually tends us to make the decision that we are going to reject the null hypothesis. So type 1 error, that is probable, and its probability, which is alpha, which implies that probability of rejecting the true null hypothesis. What is it? Probability of rejecting the true null hypothesis. We call them type 1 error, and it is also be called a significant level. There is another scenario that in our population, this can be the case that our alternative hypothesis is true. I mean, you can say our null hypothesis is false. Takes example of mean is equal to is not equal to 120. So what happens that we go and collect the sample, and in the population it was true that mean was not equal to 120, but due to some sampling error or due to some sampling issue, we obtain that the mean is equal to 120. This is the another kind of error we are committing, and probability of that error is called the beta. Graphically, if we can see that our hypothesis, null hypothesis was true, I mean most of the observation lie here, but this observation, I mean there are few observations which coincide with the values of the null hypothesis, the distribution of the null hypothesis, and researcher looks at these values and make the decision that yes, our alternative hypothesis is not true, or we can say he makes a decision that our null hypothesis is true, although most of the observation lie at the at the value of the null hypothesis, alternative hypothesis. So this kind of error we call them type 2 error, and the probability of the type 2 error is called as beta. That is, beta implies that we fail to reject the null hypothesis when it is exactly true, or we can simply say we accept the null hypothesis when it is false. Okay, then we have one more condition, and this is the last one, and it is the most important also, that we start our experiment with the assumption that our null hypothesis is false, or we can say our alternative hypothesis is true in the population, that is mean is not equal to 120, and in the end our sample data also produces the same result, that mean is not equal to 120 here. So what we are doing that we are accepting the alternative hypothesis when it is true, or we can say we are rejecting the or false null hypothesis when it is not true. This is called as 1 minus beta, and 1 minus beta also gets power of the test, and which implies the probability of rejecting the false null hypothesis. Beta is probability of rejecting the false null hypothesis. This is the power of the test. So in our hypothesis, we work with these kind of error. We work with these all four possibilities, but basically our main concern is with the null hypothesis by checking the mean value. When checking the test statistics in the computation, because the null hypothesis contains the value of equality, so the formula requires a single value. So that equality will help us out to compute the test statistics. And we know that if in the end the null hypothesis will be rejected, automatically our alternative hypothesis will be accepted. So we can take any one of them, but since the null hypothesis contains the value of equality, so we prefer to work with that one because we are going to use it in the formula. So we are taking the so for the step number 2, since we talked about at this step we define the error of the deviance between the sample values and the hypothesized value. So we take the error of null hypothesis 2, which is the type 1 error when the true null hypothesis is true. Since in the next step we have to actually take the probability. So we are taking the probability of the type 1 error, which is alpha. So this alpha we call them level of significance, which is actually implies certain level of significantly rejecting the null hypothesis. So step number 2 is level of significance. We take the probability at most 0.10, and there are standard that is 0.01, 0.105, and 0.10. The most used alpha is 0.05. When it is not given, we take 0.05. Otherwise, if it is defined by the researcher, we take any one of them. Synthesizing is basically the quantity based on the sample data and the null hypothesis, and it further helps us out to reject or accept our null hypothesis. So there are many test statistics, which is a different topic. Which we will study like t-test, f-test, z-test, chi-square test. There are many tests based on the parametric and the non-parametric observation. This covers in another session. Step number 4 is rejection and or region or the critical region. It is a value based on the test statistics for which we reject or accept an null hypothesis. Since this is the era of the software, which usually generate the p values, critical value is based on the test statistic. P value we obtain, although it is also actually derived from the test statistics, but its limits are actually fixed. So we can work out on the p-value criteria. So here we go. What is the p-value? Basically, it actually matches with the level of significance, but it is not exactly the significance. It is the observed significance level. The level of significance which we discussed in step number 2, that was we said before the experiment conducted. When the experiment conducted, then we obtain the sample value. From that sample value, we obtain the probability, that level of significance. If just we discussed in our example, let's consider the blue graph. This area is this is the distribution of the null hypothesis, and this area is of the 1 minus alpha, and this area is is of the alpha, and alpha is probability of rejecting the true null hypothesis, the area which coincide with the distribution of alternative hypothesis. So if we set the alpha as, let's suppose, 0.10 or 0.05 or 0.01, any value less than 0.10, so if the p-value comes to the, I mean, less than alpha, so it will falls in the area of alternative hypothesis. So what happens? The p-value must be small, a smallest value by which we reject the null hypothesis. So p and the criteria is then set that reject the null hypothesis if p-value is less than equal to alpha. If p-value is more than alpha, it will lie in the white area. I mean the area of the null hypothesis, far away from the alternative hypothesis. So if p-value is more than alpha, we are accepting the null hypothesis that, and if p-value is less than or equal to alpha, we will reject the null hypothesis. Then step number 5, we do the computation like using any software, and then based on the software, based on the output from the software, we make the conclusion that software that output yields the p-value. So again, based on the step number 3 and then step number 5, if p-value is less than or equal to alpha, we reject the null hypothesis. If p-value is more than alpha, we fail to reject the null hypothesis. So these were the steps which we have covered in this lecture, that we define the two statement. One is null hypothesis and alternative hypothesis. It is a summary like null hypothesis is contains the value of equality, and alternative hypothesis is does not contain the value of equality. Then we define the level of significance like alpha is equal to 0.05. Then we define that that's a statistic which we will discuss in detail later, but simply it based on type of data and the statement of hypothesis. Like it is different for the ordinal data, it is different for the categorical data, it is different for the qualitative data, and it is different for the. It is also based on the statement of hypothesis whether we want to study difference or equality or association or correlation or anything. And then we define the rejection region, that if we will reject the null hypothesis if p-value is less than or equal to alpha, otherwise not. And then we compute in the statistical software, like our concern is more with SPSS, which we'll cover in the next lecture, in all the other lectures. And then we, based on the above steps, we conclude, we find the result, and we conclude the null hypothesis. That we conclude the about that whether the null hypothesis is true or not true. This is about our today's lecture. The other concept is will be discussed in other lectures.